Alrighty, we're back for the next part of aerodynamics. This is lesson 8.2. So let's get to it. We're going to talk about spins in this lesson. We're going to start off by talking about spins. And spins are kind of a more complex maneuver to perform. It's a type of aggravated stall. So you have to stall an aircraft in order to spin it, cause the aircraft to rapidly descend in a corkscrew. Normal category aircraft are prohibited from doing spins. You can do spins in utility and acrobatic aircraft, though. An airplane must be stalled to spin, and a spin happens when the aircraft stalls and is not coordinated. So basically, you're here in a stall, you push on the rudder, the plane's not coordinated, and it stalls, and it gets into a twisting motion that then spins downward. Um, you don't have to demonstrate stalls as a private pilot. It might be a good idea to, spins. You have to do stalls. You have to do a lot of stalls. You don't have to do spins to get your private pilot's license. It used to be a requirement, I think, a long time ago, but it's not one anymore. It's a good idea to see them, though. So if you have a flight instructor who's proficient at them, or you know somebody who's really good at teaching those kinds of maneuvers, I would definitely recommend trying them before you get your private pilot's license. In order to become a flight instructor, you have to recover from a spin, no matter what. But let's keep rolling here. Alrighty, let's see. All right. So this is a type of graph here that basically is the center of gravity loading graph. We haven't gone over these graphs yet, but you have to trust me when I say when you load an airplane, you figure out where you fall. And you got to fall somewhere inside this, what's called this envelope here. If you're inside this part of the envelope, you're in the normal category. And if you're inside this part right here, you're in the utility category. You can only spin it if you load it in the utility category for this type of airplane. Let's look at some spins here, though. This is called an erect spin. This is where you basically go around. This is like what we basically practice as flight instructors. This is an inverted spin. The plane's upside down and spinning. It's really hard to recover from because your controls are backwards. And you also may not have good aerodynamics over the tail or the rudder to recover. And then you have what's called a flat spin. This is when you're only yawing around the vertical axis and spinning. Flat spins can be very deadly for a lot of pilots. They're really hard to recover from. So let's look at the forces during a spin. One side is more stalled than the other. I've never really liked this definition of it because either a wing is stalled or it isn't. So I would say this one's a little less stalled because if you think about it, it has a different angle of attack. So if you're in a spin and you're spinning downwards, this wing that's on the outside of the rotation is getting a little bit faster airspeed, a little bit faster rotation, whereas the inside wing is not moving very much. I mean, it's barely moving at all. It's right here on my finger, whereas this outside wing is moving quite a bit. So it may have some more airflow over it, therefore creating what's called a less stalled situation. You also have a different lift. You have more lift on the outside than the inside, more drag on the inside than the outside. And there's a lot of aerodynamics going on there. We'll go over that more in class when I can actually explain it more clearly. Now, how do you get out of a spin? You're in a spin. So during spin recovery, you're just trying to break that critical angle of attack. Remember, you have to be stalled in order to spin. So you're really trying to get out of this stall that happens to be corkscrewing downwards towards the earth. So you want to stop the rotation. You want to break that critical angle of attack. And you want to get the aircraft going back straight and level. So the way we remember it is and the problem, that is your ailerons really aren't working. They don't have enough airflow over them. But what does have a lot of airflow is your rudder. So use your rudder and your elevator a lot to try to get back to straight and level flying. And I remember it as PARE, pair. Number one, power to idle. So make sure your power is all the way out to idle. That throttle's all the way out. Neutralize the ailerons. Don't try to roll your way out of a spin. Go full opposite rudder in the direction of the spin and make sure you push forward on the elevator, try to break that critical angle attack. Even though your nose may be already down, you're trying to push more air over those wings. That's what you're trying to do. Quick review of that. Stall. We already did that. Did that. We talked about those things. All right, let's talk about weight a little bit. We talked about lift and stalls. Let's go to a different one of the four forces, and let's talk about weight. So weight acts on an airplane from the center of the airplane towards the center of the earth. It varies with the equipment installed, passengers, cargo, and fuel. So your weight on your plane could vary depending on these things. The total weight may decrease during the flight due to fuel consumption. So you're burning fuel while you're flying, so you're losing a little bit of weight. You're probably losing about 30 pounds an hour because you're burning about 6 or 7 gallons an hour, and gas weighs 6 pounds a gallon. And that's the end of 8.2.